Hi, everyone, and welcome to Module 5, Lesson 4, where we talk about net ionic equations. Now, the notes for this lesson are not going to be very long, but that's because I want you to have time to practice doing this. It's 3 very simple steps in order to do a net ionic equation, and it just basically practices our formula writing and double replacement reactions. But it's one of those things that you just need to do repetitively in order to get it down. So those 3 steps in order to do a net ionic equation, the first step is the complete balanced equation. So right here, we have a hydrochloric acid reacts with zinc sulfide to produce dihydrogen sulfide gas and zinc chloride. That's an unbalanced equation. So the first thing we need to do is balance that. And to balance that, all we have to do is simply put a 2 here. So step 1 is done. Now in this example, it's pretty easy because we didn't have to predict the products or write any of the formula. So simply put, that's step number 1. Step number 2 is then to write the complete ionic equation. Now, the complete ionic equation takes everything that's aqueous and breaks it down into its ions. Pure solids, liquids, and gases are left alone. So anything that's aqueous, I'm going to break it up into its ions. So I'm going to have 2 hydrogen ions, because we balance this, plus 2 chloride ions, plus zinc plus 2 aqueous, plus sulfur negative 2 aqueous. Now the dihydrogen sulfide gas is a gas, and so I will leave it alone. And I'll just write it again, H2S. Now I'm going to have zinc plus 2 aqueous, plus 2 chloride ions, ZnCl2. Okay, that's step 2. Step 3 is then your net ionic equation. In order to get rid of our net ionic equation, we have to get rid of things that are called spectator ions. So a spectator ion is not directly involved in the reaction. So it's an ion that you see on both the reactant and the product side. We can get rid of those. For example, I've got zinc ions on both sides. See you later. I've also got chloride ions on both sides. Whatever's left should be your balanced net ionic equation. So 2H plus aqueous plus Z or sulfur negative 2 aqueous. Sorry, someone's calling me. Gives me H2S as a gas. So what is a net ionic equation? It's basically showing you, what do I see happening? What is actually involved in this reaction? So it's the 2 hydrogen ions reacting with a sulfide ion to give me the dihydrogen sulfide gas. That's what is happening. That's what I can see. So we'll do another one. Here we have to predict our products, balance the equation to do step 1. Okay, so this is 2 ionic equations, 2 ionic compounds. So I'm going to double replacement reaction, swap the positive parts. The lead will now be with the iodine, and the sodium is now with the perchlorate. So here's when you go and swap to your solubility rules. I'm not going to pull it up because it's going to literally erase everything. If you look at your rules, the iodide ion for lead 2 iodine, that's going to be solid. And the sodium perchlorate is going to be aqueous. Okay. If you are still confused about how to get those things, please make sure you ask in class and I can go over it. Then we need to balance it. I've got 2 perchlorates there, so I need a 2 there, and then a 2 there for the sodiums and the iodine. So that's step 1. Step 2, take everything that's an aqueous solution, break it up into its ions. Make sure you keep it all balanced. I'm going to leave the lead 2 iodide by itself as a solid. We've got the 2 sodium aqueous plus 2 ClO4 -1 aqueous. Now, next thing we look at is what ions can I get rid of? What are my spectator ions? They're spectating, they're watching, they're not doing anything. So that would be the sodium ion. See you later. And the 2 perchlorate ions. What do I have left is my step number 3, my net ionic equation. What is actually occurring, which you can actually see happening. Lead plus 2 aqueous plus 2I- aqueous gives me PbI2 as a solid. And those are the 3 simple steps to doing a net ionic equation. Okay, so I'm going to pull up the homework and we're going to work on another one together. And when I say together, I mean you're going to watch me do it while I talk about it. So here's the module 5, lesson 4 homework, and we'll do number 2. Let's do number 2 because it's not a double replacement reaction. So first, so for number 2, it says write the complete balanced equation, the balanced ionic equation, and then the balanced net ionic equation. So copper metal is placed into a solution of silver nitrate. For the sake of this, let's say that copper is more reactive than silver. I believe it is because I think silver is all the way bottom of your activity series. So now silver will be by itself as a solid, and then copper will now bond with the nitrate. We have to pick our charge. I'm going to pick 2, CuNO3, 2. All nitrates are soluble, so that one's going to be aqueous. Now to balance it, the coppers are balanced, the silver's balanced. Oh, nope, I need to put a 2 there for the nitrates and a 2 for, oh, see, that's why I like to do the line, because I just had to shove it in there. Okay, so now I'm going to take everything that's aqueous and break it down into its ions, leaving alone the solids, liquids, and pure gases. So CuS plus 2 Ag plus 1 aqueous plus 2 NO3 -1 aqueous gives me 2 Ag as a solid plus Cu plus 2 aqueous plus 2 NO3 -1 aqueous. Okay, now what can I get rid of? I can only get rid of the nitrate ion. So what's left is my net ionic. So that'd be Cu solid plus 2 Ag plus 1 aqueous gives me 2 Ag as a solid plus Cu plus 2 aqueous. And that's it. So this is an example where it's not a double replacement reaction, but you can still do your net ionic. Remember, pure solids, liquids, and gases are untouched. You leave them alone, you just write them over. It's super important that you start with a balanced equation and you keep that throughout. And it's also important that you understand how those solubility rules work. Okay, if you get the solubility incorrect, then your net ionic equation is going to be incorrect at the end. And again, this is just basically more practice with writing formulas, okay? Make sure that you include your states of matter in each thing, and make sure that when you're breaking them up into ions, ions have charges. Make sure you include the charges there with them, okay? And that's it. I want you to use the rest of your time before we come together working on the rest of these 10 problems, okay? This isn't hard, but you have to do it in order to basically be good at it, all right? Let me know if you have any questions, and I will see you back in class.